Okay.
But if we get down to the virgin and it's a client that's counting carbon, right? Because one of the big challenges with virgin lumber is the energy footprint is 90+% compared to reclaim. So it takes 90% less energy for us to reclaim a board coated material than it does for virgin because ours is already dry, right? I don't need to fire up a kiln and dry this for days by the train load. Our stuff is dry and straight and ready to go. So for those that are looking for a premium product, much smaller carbon footprint, like they say, the best product to select is one that already exists.
Yeah.
Right. Don't go make something new. Don't go build a new product. Use one that already exists. That's a huge carbon reduction in your embodied carbon for your building. If you're using reclaimed lumber, it's a dramatic reduction in the transportation carbon because it's locally sourced, right? We're not trucking it or training it thousands of miles to get it to the customer. It's already typically in that metropolitan area. And it's already cut to shape, right? I don't have to dry it. I don't have to replane it or mill it. Typically, they're already the right dimension. And then if you want, we can clean it up a little bit, but it's locally done.
And are they already factoring carbon into their businesses? No, I'm talking the construction company that's taking this in to build a new project.
So some are. Very few of the contractors, it's typically the owners. So all the owners that have, carbon goal of net neutrality by 2030, 2035, if they're doing it correctly and they're looking at their total carbon footprint, they have to look at the carbon in building those buildings. Can't just look at the carbon to operate them, right? To heat them and cool them on an annual basis. You have to look at your full carbon footprint. And there's a lot of owners starting to do that. They're starting to look up and say, okay, I can offset my operational carbon for my heating and cooling and lighting loads. But what about the debt I have from building this building? And if you built a big concrete
full life cycle,
exactly, that debt is massive.
Right.
Typically, often it's in the operational carbon in the life cycle of that building.
So how hard is it to build robots to strip nails out of lumber? Because that seems like a pretty gnarly problem. I would love to hear about your whole journey here, because that seems like a really tough problem.
It is. The nice thing about it is it's easier than sorting garbage. There's a whole bunch of robotics companies out there that are trying to sort recyclables and garbage and do all that because, there's only so many types of nails, screws, and fasteners, right? If you look at like a municipal waste stream compared to what we're doing. So our problem is easier than that. It's still incredibly hard.
Interesting.
It's still a really hard problem. But the nice part about it is the consistency of the fasteners coming through. They change a little bit with the age of the industry.
Sure.
Before 1980, we don't see much for screws, right? Because they really didn't start showing up until the 80s and 90s. But 16 penny nail, we're seeing millions of those, right? They're bent over in different directions and they're all smashed or they're straight or they're crooked, whatever. But that's just a training algorithm problem. And so it's really us just building our data set and training these machines on how to respond to those different orientations. And then we built all of our own end effectors because the existing off the shelf ones weren't going to hit the unit economics in terms of speed and performance.
Sorry, say that again. You built our own
robotic arms.
Okay.
So all the arms that you see in our videos, those are all built by our engineering team, designed and built by our engineering team.
With all the robotics, the industrial robotics at around from Fanuc or any, name your top 10 robotic suppliers in the world, particularly probably automotive, I would think, or industrial. None of those were suitable?
Nope. Because they're massive, right? In order for them to get their massive strength, their big arms, because they're used to picking up a car or a tire or that. And they're used to, hey, let's go move the tire around in 3 dimensions, 6 axes. We didn't.
Okay.
We just needed strength in a single axis. And then, the other side of the spectrum is you got the microchip folks, right? Really high speed, low weight, incredibly fast arms, moving that. We had to merge those two together. And you get the strength in a single axis of a big industrial. I want the speed of semiconductor lines. And so we looked at those two kind of for inspiration and ideas. And ours is a combination of those two. It's the best of both worlds. So we get the strength and the axis we need to pull a 16 penny nail. Our arms are pulling, 700 to 1,000 pounds of pull force to get a nail out. But they're moving with the speed of a microprocessor line.
Okay. So give everybody some context. How big is this machine and how big can a piece of wood be that comes through this machine?
So the machine is 80 feet long. Is our process line.
This is a big operation then.
It's a big operation, but we're not building cars.
Yeah.
right? So we're kind of somewhere in the middle, right? So it's
Yeah.
an 80-foot long process line. It
Okay.
rides on two 40-foot trailers.
All
So
right.
it's portable. So we can go out to the job site and clean on the job site, which is beautiful because then we can ship on flatbeds coming out of there. And within this line, we've got brushes, we've got pullers, we've got x-rays, we've got metal detectors. There's multiple steps to getting this thing clean at the end and saying, hey, dear customer, this is metal-free wood, right? There's a whole lot of steps it's got to go through. But it's awesome to see the material run through it. And we can process everything from, a 2x4 cross section, so 1.5 inches, 3.5, on up to 6x18. And the pieces can be 6 feet long on up to 40 feet long. So we can run a massive timber beam through our system or a big glulam beam through our system and take all the metal out of it and then ship it off to a customer.
That's incredible.